Warahmatullahi wabarakatuh. Introduce, my name is Rasito. I will present our paper entitled Development of a Single Moderator Based Neutron Spectrometer. Our paper is the result of a review of papers that publish the results of the development of a moderator based neutron spectrometer from multi-moderator to single moderator, which has been developed since the 1960s until now. Neutrons are uncharged particles that constitute the nuclei of atoms. Neutrons can escape from the atomic nucleus due to various physical events in the atomic nucleus. When a neutron is released from the atomic nucleus and become neutron radiation, it will interact with the material in its path. Neutrons' interactions are very dependent on their energy. Therefore, the measurement of neutron energy becomes something very important to do. Neutron radiation around us. They can come from various sources, both natural and artificial. Neutrons in the nature can come from cosmic radiation when interacting with the atmosphere. Neutrons can also come from nuclear reactors, neutron generators, medical LENAC, cyclotrons, and radioactive sources. Neutrons originating from these various sources have a diverse energy spectrum. Cosmic rays have a very wide energy spectrum, from the order of milli-electron volt to giga-electron volt. Nuclear reactors have an energy spectrum of the order of milli-electron volt to mega-electron volt. Neutron generators have a fast neutron energy spectrum that varies depending on the target material used. Cyclotron can produce neutrons with an energy spectrum that is dominated by fast neutrons and few thermal neutrons. Medical LENAC produce neutrons with an energy spectrum that is dominated by fast neutrons and also few thermal neutrons. And the radioactive source such as MB produce neutrons with a fast neutron energy spectrum. To be able to measure the neutron energy spectrum, a neutron spectrometer is needed. This is a table that shows a list of types and characteristics of neutron spectrometers that have been developed, starting from the recoil counter, organic scintillator, capture gated, helium ionization, semiconductor, time of flight, activation, bubble, and multisphere. In terms of the ability to measure the neutron spectrum, the neutron spectrometer that has the widest energy range is the multisphere spectrometer. Multisphere is a multi-moderate based neutron spectrometer type. If this is an open neutron detector in open condition, then when we expose to neutron radiation, the detector response has the shape of this blue curve, this one. Meanwhile, if the neutron detector is placed in a moderator containing rich hydrogen atoms such as water, polyethylene, paraffin, and plastic, then when we expose to neutron radiation, the detector response has the shape of this red curve. That is, by giving a moderator to the neutron detector, the number of interactions is greater, and the measured neutron energy is also greater. If the position of the detector in the moderator is varied in depth, the detector response to the neutron energy shifts to a higher energy. This is a physical phenomenon that is used as the basic concept of a moderator-based neutron spectrometer, where the detector position in the moderator can produce a different neutron energy response. The moderator-based neutron spectrometer design was first developed by Bonner et al. They use 5 spherical moderators made of polyethylene varying in diameter from 2 to 12 inches. The detector used is a lithium scintillator. The image on the left shows the geometries of the moderator and detector, while the image on the right shows the response curve of the 5 detectors. This design has the disadvantage that the measurement must be carried several times according to the number of balls or spherical. Besides that, this is also very heavy and impractical. In 2001, Taniguchi et al. Modified the Bonner moderator design, where the solid spherical was converted into a layer spherical. Yes, the solid ball was converted into a layer ball. In this design, it is relatively lighter and more practical, but the number of measurements is still carried out several times according to the number of layers of the ball. In 2008, Gomez-Liz et al. Modified the Bonner moderator design, in which multi-moderator were changed to single moderator. The result of this development obtained a spectrometer that is lighter and more practical, and the measurement is only done once. This design used 43 passive detectors mounted on the XYZ axis. The following table shows the results of the validation carried out from 4 designs resulting from the development of a single spherical moderator spectrometer, where the Zhang design in 2021 validation results provide the best value. Not only spherical, the development of a single moderator neutron spectrometer also includes a cylindrical shape. In contrast to sphere, whose applications are for multidirectional measurements, cylindrical designs are generally intended for one-directional beam measurements. This design was first developed by Harrison et al., and they use a polyethylene cylinder and using lithium fluoride as a detector. With the same detector, Bedogny et al. Also developed this spectrometer with a slightly different material, namely high-density polyethylene, HDPE. This table shows several types of single-cylinder moderator neutron spectrometers with their respective validation result. And this table shows the use of active and passive neutron detector in the development of a single moderator neutron spectrometer. The most widely used detectors are lithium, then helium-3 and dysprosium. This table shows that there are still many unused neutron detectors. As a summary and outlook, there are still great opportunities in this development of a single moderator-based neutron spectrometer, both in the form of a moderator and in the type of neutron detector used. And this is a list of papers we reviewed. Thank you very much.